But another thing we can do, like I said, if we look at the Excel stat box plot, this tells me kind of, it's called relative standing, how the data values compare to each other. And so one measure of relative standing, but it's also a measure of center, is right here, this line in the middle of the box plot. That's the median. Okay? So maybe I should say this. When you go to section 3.4, which is measures of relative standing and box plots. The box plot looks something like this. Okay? And what it's supposed to be, this is a visual representation of what is called the 5-number summary. And the line in the middle of the box, this is the median. Do you remember how we got the median of a data set? That was where we started. I remember Laura told us, hey, just start chopping off the endpoints, right? Until you get to the very middle. And that middle value, the median, is what is the middle number in the 5-number summary. So what's that going to be for our example? What's our median? Well, or A, either one. 12, right? For any of them, it was 12, right? Now, the other numbers here, okay, this is going to be the min, and this is going to be the max. And so you'll notice when I look at the box plot that Excel drew for our data, the top line up there is 15, and the bottom line, oh, okay, so I have mine upside down compared to that. I've even seen them sideways, all right? So let me match it up with theirs. They're putting the max up top. I guess that makes more sense. And the min down here. Okay? There are two other numbers which we're not familiar with yet. They're called Q1 and Q3. Okay? Let me explain what Q1 and Q3 are. One way to say what Q1 is, it's kind of the median of the lower half of the data set. What do you think Q3 is? The median of the upper half of the data set. Okay? So that's very quickly what they are. It's like if all the data was lined up, 25% of the data would be represented by this line, 25% of the data would be represented by this box, 25% of the data would be represented by this box, and 25% of the data would be represented by that line. And so what you're really doing with the data is you're talking about, hey, how do these data values compare with other ones? Okay. And as you work on the homework tonight, I think that'll help you just have an understanding of what these are. Okay. If we look at the 5-number summary again, for our original, this is the original data set, what would be Q1? Well, it looks to me like it's below 11, right? But it's above 10. Okay? So I think it's actually, around 10 and a half or something like that. They list the actual values that they computed for me up here. You notice it says the first quartile is 10.75 and the third quartile is 13.25. Okay? So these are computations also that kind of tell you ballpark what's the data like. Okay? And as you do the homework, you're going to learn about something called percentiles. You've probably heard about percentiles before from the tests. Maybe the first thing to understand is that the median, guess what percentile that is? 50th percentile. It's greater than 50% of the data and it's less than 50% of the data. The quartiles correspond to the 25th percentile and the 75th percentile. So I hope that makes some kind of sense. And as we work on homework, I think we'll understand more. The question Dylan was asking about was on the next page here, is number 25. And it asks you to construct back-to-back stem plots. Okay? And no, you're right. This is not a quiz question. This is a homework problem. Well, there's a lot of things I'll ask on homework that I don't have time to ask on the quiz, right? But it's not as hard as you think. Matter of fact, let's look at exercise 19 where they do one. Okay? So it says turn back to section 2.3. They already have one for you. So let me find it. What was it? 29? No. No, I lost it, guys. Yeah, that's what I thought I said, but then I went to section 2.2 and I couldn't find it. Okay, here it is. Exercise 19. I think I'll zoom in a little bit so you could see the graph a little bit better. So we have actresses and actors. And it says sometimes a good way to handle, well, a situation where you want to make comparisons between two groups is back-to-back relative frequency histograms. Okay? So, just so you guys understand, I don't think I've talked yet about relative frequency. And so I think maybe this is a good time to do that. And then maybe this will make sense. But you'll notice that the axes of the bars, right, instead of being frequencies, we have percentages. Right? We have percentages. And so maybe if I turn back, let's find another frequency distribution. Well, like we were working with number 10 the other day from section 2.2. I remember this problem. Remember the white blood cell count? Yeah, we did some work on that one. So 6, 16, 9, 7, and 2 are the frequencies, right? I think we might have even made a histogram for this the first day. Okay, so I have frequency. It was 6, 16, I want to go ahead and label these, 9, 7, 0, and 2. Okay? Sometimes what is done is people will graph relative frequency. What does that mean? Well, to do relative frequency, what you're going to do is you will divide each number, each value, or each frequency, so you know exactly what you're dividing, by n. What does n stand for again? N stands for the number you have this, it's called the sample size, right? What's our sample size here? I guess I could get it, right? I could get what n is by adding these up. 22, 31, 38, 40. Oh yeah, I remember that from the time we did it. So if these are the 40 sample values, right? And if you do 2 divided by 40, that's 1 divided by 20, that's 5%. And so I could list it as either 0.05 or I could list it as 5%. This one would be 0, right? Where it says 6 divided by 40 is the same as 3 divided by 20, which is 15%. Of course, this is easier with a calculator. There's no doubt. Okay? 16 divided by 40, 8 divided by 20, 4 divided by 10 is 40%. 9 divided by 20, I think, would be 0.225. I'd have to check my math on that. And 7 divided by 40, calculator people. Do you get 0.175, I think? What the point is that you can graph the relative frequencies instead of the frequencies. Your histogram will look the same, but what do these numbers represent? Well, the point is that they're percentages. They all have to add up to what? 1 or 100%. Right? So sometimes that's done. That's called relative frequency distribution. That's what's done in this picture, this homework problem, is they take data and they do relative frequency distributions, but then they put them back to back. And so you can really compare the ages of Oscar-winning actresses and actors, right? And so it's showing me that, well, let's see, 40% of the actresses were in the age range 29 and a half to 39 and a half. 30% were in the range 19 and a half to 29 and a half. Okay? And I think what they want you to do is just kind of continue. But I think that other problem was just basically try it again with a larger data set.
There's numbers.
So they gave you data numbers, right?
Yeah, they went back to back. I don't know how they found the numbers.
But I think you had to download the data set. Yeah, I'm not going to worry about that too much. Okay? But at least it got us a chance. And guys, there was one more kind of frequency distribution that I didn't talk about. It was called cumulative frequency. Let me show you that. Cumulative frequency. When you do cumulative frequencies, what you do is you kind of add them up. I guess to show this, it would be wise for me to remind you what we were actually counting here. I think we were counting white blood cell count. Yeah. And so you might remember that we had how many white blood cells, or what was your white blood cell count? And so this was like 3 to 4.9, and this was 5 to 6.9, 7 to 8.9, 9 to 10.9. We didn't have any from 11 to 12.9, but we had 2 people that you guys thought were probably sick because their white blood cell count was especially high. You guys remember that data? So now what I do when I do the cumulative frequency is this. Instead of, I'll still call this one 6, but the next one I'm going to say 22. What am I saying? I'm saying 22 people had a white blood cell count that was less than or equal to 6.9. The next number I'm going to write down is 31. What is that telling me? 31 people had a white blood cell count less than or equal to what? 8.9. You basically are adding up the classes. You might say, why would you do that, Paul? Here, less than or equal to 10.9. Do you guys know what I'm going to put here? Good, because I add on that other 7. Less than or equal to 12.9 would still be 38. And you know, you might say, Paul, why would we do this? Well, maybe I know that as long as my white blood cell count is less than 11, then I'm okay. I don't need to wear a mask. Now, I don't know what the rules are, guys. I don't know. But if I know that, this would tell you right away, oh, 38 of our 40 people were fine. Only 2 had to wear the mask. So, of course, I guess this last number will always be n, right, when you get to the last set, the last data set. Do you guys have any questions on cumulative frequencies?